Okay, here's starting with number 27. So I'm going to graph these inequalities. I'm going to put it on a grid so that it looks a lot cleaner. Notice how the slope of this line is up 1 over 1. Sorry, I didn't mean to type 0, comma 1. I meant to type 1 over 1. Up 1 over 1. So, and the y-intercept is 0, comma 7. I'm going to color code that, make it green. So the y-intercept I'm going to plot first, put that green dot there. That's the y-intercept. And then red, I'm going to go up 1 over 1, up 1 over 1. And I'm gonna put little dots to show that I'm going up 1 and over 1. I can go left 1 and down 1 too, but either way, I draw the line, and because it's greater than or equal to, it's a solid line, and then you just shade above. And that's you could also graph this line using a table if you want. So feel free to use a table, but I just plot the y-intercept and use a slope. This one, it's a absolute value symbol, so it's gonna be a V shape. First, I'm gonna find the vertex. The x coordinate of the vertex is gonna be whatever makes that absolute value stuff 0, but then it's shifted down by 3. Notice how I'll put in yellow here. That's where that -3 comes over because it's shifted left by 3. But then blue highlight is it shifted down by 3. They're the same number, but for different reasons, and it's a V shape. I can roughly sketch it, but I want to be a little more accurate. That 2 is going to make it a little steeper. So see, I'm going to go up 2 over 1. Again, you can use a table of values if you want, which I'll do that in a second. I'm going up 2 over 1, up 2 over 1. I know it's an absolute value. It's a V shape. So I'm just plotting those points. And another way you can get these points is you can just guess and check x values, but I'm just drawing a perfectly straight line. Now, it's not supposed to be a solid line, right? Because it's just greater than. So it's supposed to be a dashed line or a dotted line, however you want to see it. So I just take my eraser and I just start erasing like little gaps. So I just erase a little gap, erase a little gap, and that way I make it a dashed line. It takes less time for me than like trying to actually draw a dashed line, and I find it a lot cleaner. So I also need a shade above, and that's what the greater than means. Greater than, shade above, whereas less than means shade below. I'm going to show you how to generate the table. Now, I'm going to do it on a calculator. You can generate the table by guessing and checking x values, but you can do absolute value 3 ways. Second catalog, you can go to the math menu. You can go to number, absolute value that way, and I just show you the 3 different ways. Or you can go to second, or you can go to alpha window. All those get to it, but I'm going to go to my second table and generate my table values, and I'm going to type in like, just some random x values that are on the grid: -5, -4, -3, -2, -1, 0. And notice how you can just start plotting the points. All of these table values right here match up to points that I have on the grid, and you can pause the video and confirm that, but those are all ordered pairs that are on here. 29, I don't like it not being in slope-intercept form, so I'm going to put it in slope-intercept form. I'm going to move the 4x over by subtracting 4x in each side. And then, so get that in slope-intercept form means get y by itself. But, oh, wait, I got to divide by -3. Since I divide by -3, it flips the inequality. So instead of it being a less than, that's why I end up with a greater than. So this is still the graph of a line. And the y-intercept is kind of annoying. It's not a perfect whole number. So it's almost -1, but not quite. So I'm going practically to -1, but not all the way down. And then my slope, I just go up 4 over 3, up 4 over 3. And so I graph that line, and I'm going to shade above. But again, I'm going to erase little parts right there to make it a dashed line or a dotted line. And again, the inequality flipped because I divided by negative, shade above, and it's all wrapped up. This is another absolute value sign. Again, I can do the table values, but my vertex x coordinate is going to be -2 because -2 is what makes the stuff inside the absolute value symbols 0. It's shifted down 3, which is what the -3 does. And then the 1/2 makes it shorter, but also the negative flips it upside down, so it's an upside down V. And so I can graph this thing. It's going to be a solid line because it's less than or equal to. But I can also, again, go to my table values. I can do that slope is negative. It's like a slope of -1/2. So it's like down 1 over 2. But and you might ask, why am I going down 1 and right 2? Well, it's absolute value, so it's symmetric. So in case you don't quite understand how to do that by hand, again, you could check it on your calculator. And so I graphed that, but my window is all messed up. So instead of going to like the window that I was in before, I'm going to go to the zoom standard window, and you see how I can get a pretty good estimate of where I should be. And if I want to get more accurate measurements, like I can go and I can actually shade below in my calculator. I can use the trace function to like see points. 0, -4 is in there. And then I'm going to have buddy, you did. And so we have we can look at other points on there as well. All right. So this is just an open-ended question. I just want you to know this: a relation is not a function if it fails the vertical line test. I'm just sketching something that fails the vertical line test, and its domain, it goes as far left as -2, as far right as 5. It goes as far down as -3, as far up as 2. This is just an example, but know that this is not a function. It fails the vertical line test. Um, this you don't really have to know necessarily, but it's just something that's neat. It's not something really that I'm going to test you on exactly because it's not a really thinking question. But point slope form and the slope formula are the same thing, just rewritten. This is important. Okay, so this one is shifted down 4. This one is shifted right 1. That's what the -1 inside the bracket says, and down 5. This one is shifted left 4. Remember, those behave the opposite. What do you expect? Then it's reflected across the x-axis. It's reflected vertically, you can think of. And then the +3 shifted up by 3. This one is shifted left by 1. And what does that 2 do? You might think it makes you skinnier, but again, I call it a vertical stretch of 2. It makes you taller. And I'm going to roughly sketch all of those. You can sketch them on a grid a little better, which you'll be expected to sketch them like I did before in the previous the previous questions. I'm just roughly sketching of absolute value down 4. I'm shifting it, down and over. Here I'm shifting it up and left. And then the 36, again, these are rough sketches. I can sketch them a little better. 36. I'm trying my best to make it like skinnier here. I'm trying to make it a little taller, so it's like yeah, it's shifted left by 1, and it's like I don't feel like that's skinny enough. Let me try to do like a little steeper, I guess. But notice how it's going up 2 over 1. So just try to graph that steep as you can. All right. Again, you'll be on a grid. You'll be given a grid for that. All right, we're gonna do a trend line. This is the most important part. You do not have to on the test to actually make a scatter plot. I don't want you to like draw and an x-axis, a y-axis, and draw scale. I just want you to put these values in. For the years, I'm not putting the years. I'm putting the years since 2001 so that my y-intercept isn't all weird. But just punch the data in. Notice how, just look at here. All I'm doing is punching the numbers from the table into my calculator. I'm putting that hidden stat first. Then I'm going to edit. And then I punch that in. Now I'm going to go to len reg, a trend line, that line reg. Make sure your x is L1. Make sure your y is L2. Hit enter a bunch of times. That's the formula. That is the formula or the equation of the trend line. If you want to see the scatter plot, this is it right here. That's it right there. But again, you're not going to be, I don't care if you can do a scatter plot. I care if you can find the trend line. And the trend line goes through, it doesn't go through perfectly these points data. It goes kind of, and this is just like the scale. These years are 2000, 2005, 2009. It's as low as 1750. It's as high as like 3300 or something. But again, the equation is what's important. Is important. You hit stat, you go to edit, you put the numbers in there, then you hit stat, go over to calc, and you do len reg. The slope is 187.58. It's not really important that you're super accurate since you're just approximate. If you put 190, I'd be okay with that. If you put 200, that would be a pretty good ballpark too. If you put instead of 1720.9, if you put 1700, that would get you close enough for a trend line. If I put the years instead of it being the years since 2000, if I put it to be the years, the actual years themselves, see how it gives me this really weird y-intercept? So that's why I didn't put it that way in case you're curious. The y-intercept doesn't make sense. I'm going to predict the value in 2015. What I'm going to do is I'm going to plug, it's 2015 means 15 years since the year 2000. So I'm going to plug in 15 for x into my equation from part B. So I'm just taking that equation, evaluating it at 15, kind of like what we did with that f of x stuff and g of x stuff, except I'm doing it in a practical application. I calculate that, you get about $4,500. Okay, and again, it's a ballpark figure. It doesn't have to be perfectly on, but I just want you to show some reason. And that's it for the chapter 2 test material. Good luck.